Assalamualaikum. My name is Muhammad Faiz bin Muhammad Sakri, and I will start with the introduction of atomic arrangement. The physical structure of solid materials is determined primarily by the arrangement of the atoms, ions or molecules that comprise the solid and the bonding forces that exist between them. In general, the main chemical bonding in solid structure can be divided into two types: primary bonding, which is strong bonds, and secondary bonding, which is weak bonds. Basically, atoms are positioned or situated in an orderly and repeated pattern, 3D arrays, which is called as crystal structure.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Arif Hakim bin Muhammad Zainuddin. Matrix number AA200502. Okay, so for the simple cubic, the simplest repeating unit in a simple cubic structure is the simple cubic unit cell. Each unit cell corner is defined by a lattice point where an atom, ion or molecule can be found in the crystal. The edge of a unit cell always connect equivalent points by convention. As a result, each of the unit cells' 8 corners must contain an identical particle. Other particles may be present on the unit cell's edge or faces, as well as within the unit cell's body. However, the unit cell must have at least 8 equivalent particles or each of its 8 corners in order to be classified as simple cubic. In the simple cubic structure, there is only one lattice point at each corner of the cube-shaped unit cell. They mark the position of either a single atom or the same group of atoms, known as the motif, which is repeated across the lattice. The simple cubic structure with only one atom per lattice point is relatively rare in nature, as it is very unstable because of its low packing efficiency, low number of nearest neighbor around each atom. Polonium is reported to crystallize in the simple cubic structure. Next, for body center cubic or BCC, the simplest repeating unit in a body centered cubic structure in the body centered cubic unit cells. Once again, there are 8 identical parts on the unit cell's 8 corners. This time, however, there is 9 identical particles in the center of the unit cell's body. The body-centered cubic structure is based on the simple cubic structure, but has an additional lattice point at the very center of the cube. The packing efficiency and the nearest neighbor interaction are slightly higher than from the simple structure, so it is more common in the nature. Prominent metallic solids with this structure are iron, chromium, and tungsten. That's all from me. Thank you.
So, I want to explain to you face-centered cubic, FCC, and hexagonal closed pack HCP. Okay, first, face-centered cubic. The face-centered cubic unit cell begins with identical particles on each of the 8 corners. This structure, however, contains the same particles in the centers of the unit cells since face for a total of 15 for a total of 14 identical lattice points in the cubic closest pack structure. The face-centered cubic unit cell is the simplest repeating unit. Indeed, the design of face-centered cubic unit cell in this structure explains why it is referred to as cubic closest pack. Hexagonal closed pack or HCP. The third layer of a hexagonal closest pack structure has the same arrangement of spheres as the first layer and covers all of the tetrahedron because the structure repeats itself every 2 layers, the stacking HCP is AB. The hexagonal closest pack structure. Atoms are efficiently occupy 74% of the space, while the remaining 26% is empty space. This is all from me. Thank you.
As a conclusion, the atomic arrangement and unit cells of each crystal structure are built different. Each model has its own number of atoms, which simple cubic has 1, 2 for BBC, 4 for 4cc, and HCP has 6. Each model unit can also be calculated using its formula.